Hello and welcome to YourPedia. My name is Aman Sharma and today we'll be doing a question from our NPTEL question bank series, and the topic that we have selected for our video is indexing from database management. The question that we will be doing is question number 65 and question number 66. You can find this question on page number 131 in our booklet. So let's move on to the question first. So in the question, you have been given some data. You have been given number of records. After that, you have been given record length. The size of the record is 200 bytes. After that, if you want to store a record in the index field, or you want to store the record information, you need primary key field which has been given as 13 bytes and size of the block pointer as 7 bytes, and the block size is 2048 bytes. So you have been given this information, and it is asking, and you are using multi-level index, and it is asking the block factor for data file and index file and the number of blocks in the first level of index file. So in order to find out the block factor, for data file and index file, you need to have the knowledge of how the data is stored in index file and the data file, how these two are different. So let's move on to the question. So you have been given, so let's assume this is a data file, and this is the index file. So in data file there are 1310720 records, and the size of each record is 200 bytes, and the size of the block of each block is 2048 bytes. So first we have to find out the block factor. Now what is block factor? Block factor is the number of records that can be arranged in a particular block. So let's say this is the formula for block factor. It is block size divided by record size. Now the block size that has been given to us is 2048 bytes divided by the record size is 200 bytes. So the block factor here will be 10.24, which will be equal to 10. So the block factor value is 10. This means each block will have 10 records of its own. Now why we are using floor value here rather than the ceiling value? Now let's take an example for it. Let's assume that the block size was 20 bytes and the record size is 3 bytes. So the number of records that you can store in it is 6.66. Now it is not possible to store half of the record in one block and half of the record in the other block. So what we can do is, and there is a limit to the number of records that can be stored in a particular block. So what we do is, we will store only 6 blocks, and the remaining, the 0.66 byte of data in the block will be wasted. So what we do is, we take the floor value of the block factor. So here the block factor come out to be 10. Now let's move on to the block factor of index file. Now in index file you don't store the whole record, you just store some data of the record, which will be the key field of the record and the block pointer of the record, which will point where the block was originally placed in the data file. So you just need this amount of information, not whole 200 bytes of the block. You just need key field and the block pointer data. So what will be the block factor here? Again we will be using floor value. So the block size is 2048, key field is 13 plus 7, which will equal to 20. So this will come out to be 102.4, and the floor value will give us answer 102. So the block factor for index file is 102 and the block factor for the data file is 10. Now what this means is, in this data file, in each block there will be 10 records, and in this index file in each block there will be 102 blocks. So if we have to find out the number of blocks in data file and in index file, so what we will do here is, we will take total number of records and we will divide it with the block factor. It is quite simple, because if you have this number of records and each block is holding 10 records, then how many blocks you will require is 1310720. So we will write the number of blocks here. In fact, the blocks will be 131072. Now in the case of index file, number of blocks will be, now in this first you need to understand what will be stored here. You will not store the records here, you will store the information of record, and the number of records that index file will have will be equal to the number of blocks. You will take data of each block and just store it in the index file. That's why there is a block pointer here. If there is one block here, it will point to some block which will be stored here. The information will be stored in the index file. So in the index file, as there were 1310720 records in the data file, in the index file the number of records will be equal to the number of blocks present in the data file. So if we store all of the blocks here, then the number of records in the index file will be 131072. So 131072 records will be placed here, and the block factor is 102. So the number of blocks will be total number of records 1072 divided by the number of records that can be placed in a single block, which will be 102, which will come out to be 1285.4. Now whether to take the ceiling value or floor value here, can you guess what will be the value we will be taking, whether it will be ceiling value or floor value? Now it is saying that you need 1285.4 blocks to store the our total number of records. Now you need, let's take an example here. Let's say you need 2.3 blocks to store some data. So 2 blocks will be full, but the third block will be half full. So if you take in consideration the total number of blocks, that will be equal to 3. You are taking 3 blocks in total, because 0.3 block will be filled. You cannot leave some records out. Just if you take the floor value here, you take 1285 blocks. So the last number of records, the number of records which will be present here in the 0.4 part will be lost. So you have to take these records into consideration also. This means that we will be taking ceiling value. So the number of blocks will be 1286. So the answer for the question will be the blocking factor of data file and index file 10,102. We will, for the blocking factor, we will be taking floor value, and the number of blocks in the first level of index will be 1286. We will be taking the ceiling value. Now if you want to expand this question further, let's say you want to expand this question further, and if I ask you what will be the total number of indexing levels for this multi-level index, then what will you do is, for the first level of index, let us go in opposite direction. So the number of blocks here are 1286 is the number of blocks. Now these blocks will be the record entries for the second level of index. If this is the first level of index, then in second level of index these blocks will work as the entry, record entry. So there will be 1286 records here, and again block factor for this index will be 102. Now if you want to look at the total number of blocks in this, you have number of records and you have number of blocks, block factor. So the number of records will be, number of blocks will be 1286 divided by 102, which will be equal to 12 point something. Again we cannot take this value as 12, because if we take this value as 12, the last 0.8 part of the records will be lost. So we will be taking ceiling value, which will be equal to 13. So the number of blocks in this level of index will be 13. Now if you want to move further, now one block can have 102 records. So if you move another level, all these 13 records will be stored in one block, because it can have 102 records. So obviously it can store 13 records in it. So one block will be more than sufficient to store all the records. So if you take data file into consideration, here we have seen that from data file you have made a first level index in which there will be 1286 blocks, and the records were the number of blocks in the data file. So the amount of blocks in the data file will act as the number of records in the index file, and by using the block factor we have calculated number of blocks in first level index. Now the number of blocks in the first level index will act as number of records in second level index, and if you use block factor in it again, then you can find out the number of blocks in second level index, which comes out to be 13. Now these 13 blocks will act as the records for third level index. Now in third level index we know that the block factor is 102. So if the block factor is 102, it means that it can store 102 records in it. So if it can, one block can store 102 records in it, then it will surely store 13 records in a single block. So the third level indexing will have only one block. So this is our question. So keep watching for more interesting questions like this, and the solution for this question will be available on our YouTube panel in a PDF format. So keep watching and keep practicing. Thank you.